Hi, hola, bonjour, privet salem. Today's video is based on CFD analysis on Ansys Fluent. The part in question is the front wing of a Formula One car. Two different meshing densities of 15,000, 41,000, and 100,000. Subsequently, the number of iterations used are 200, 400, and 520 to keep processing times low. Since it is a symmetric part, only half will be used to set up the simulation as the flow is aligned with the body. This will not be applicable in case of angled flow when that car is turning. The flow models used are k-Epsilon, Transient Shear Stress, and Reynolds Stress for the purpose of evaluating multiple schemes. The Inlet Air Velocity is set to 100 meters per second. Firstly, the 25 mm cell using k-Epsilon produced circular flows due to the mesh size being too large, which cause an error which evident from the flow not leaving the enclosure. Reducing mesh to 15 mm cells removes that error, which is not even flagged by Fluent, and produces good results. Next is the transient shear stress, with 25 mm cells, which yields a more detailed simulation result. Finally, the Reynolds Stress Model with 10 mm cells that produces the highest detailed simulation as it uses 7 equations to predict the flow and is not as simple as the k-Epsilon models. It has to be mentioned that the higher detail in the last simulation is not just because of the Reynolds model, but also due to the significantly reduced cell size